Okay, good morning class. So at this point we are busy with trig graphs. You guys had some homework? The homework was exercise 6.7. 6.7. Any issues there? You had to do the odd numbers, no? Any issues there, people? You sure? We did the homework. Right, homework is 6.7 even numbers. The next heading is trigonometric equations. Trigonometric equations. We're on page 209. We're going to read through this example now, okay? With the explanation, not the example. The example we'll do afterwards. Okay, so trigonometric equations, we're on page 209. The explanation actually. On page 209. Okay. Trigonometric equations. So solve the equation of the form sin of x equal to m. Now m is any ratio that we normally have, okay? So here we are told that solve for x, for sin of x is equal to a half x, where x is an element of negative 720 to 720, which means to say the graph from negative 720 to 720. Okay, that's basically what it means. At this point you know how to draw a graph, okay? So if you look at this graph here, the sine graph, if you draw the sine graph from negative 720 to 720, this is what the sine graph is going to do. You're going to draw the graph to 1020, the graph is going to go there. Okay, and then 2000 and so on. So this graph carries on and on and on, in the positive and in the negative direction. Not so? Whilst the maximum value is 1 and your minimum value is negative 1. You go through all the way to infinity and all the way to negative infinity. So what they do is, they restrict the domain, so the graph is just drawn between those points. Because I imagine you must draw an infinity graph, it will take you a lifetime and beyond. No? To draw that graph to infinity. Okay? So, as we are told here, the following graph represents, the following sketch represents a graph of y is equal to sin x. And y is equal to a half. Why did we go with the half? Because of what we have. Okay. So if you look at this graph here, and I draw the line y is equal to half in here, what do you notice? The graph is going to be there, and there. Not so. So these are corresponding x values. Corresponding values on the graph, where that y is equal to half is going to cut that graph. Do you all see that? Okay. So now, if that is the solutions they are looking for, then what is it? X would be an element of, and we list. The first one is 30. Can you see here? That was 30. This one here. This is increments of 30, so that's going to be 150. Can you see that? This one here, this is 660, so it's going to be 390. 360, sorry. This one here is 540, so 30 less, 510. Not so, 510 degrees. On the other end, here we have negative 180 minus 30 is negative 210. Can you see that? On the side, negative 360, 30 before that is negative 330. Here we have negative 540, 30 smaller than that, negative 570. This one here, this is negative 720, 70 prior to that, 30 degrees before that, it's going to give you negative 690. You guys understand? So the question is solve for x, where x is equal to half. The solution is all of the same. Can you see that, people? Right. But what if, let me just show you something quickly. What if that graph, I'm going to take the same scenario, I'm going to draw this graph here. And it carries on now forever. Negative infinity and positive infinity. Okay? Oops, that one's a bit low. You all agree it's the same graph, no? Because I can't draw a smooth, whatever, carrying on now forever and all of those things. The graph is, of course, carrying on forever. So y-intercept, that's 0. That's your x-intercept. Not so. So if I draw the line y is equal to half in here, what do you see? The graph will go on forever. Not so. So if you're going to hit here, it's going to be 30, 150. It's going to hit there. So what do you notice? How many times will this graph be cut to infinity? An infinite amount of times. Not so. It will carry on. As long as that graph carries on, this line y will equal the half, will cut that graph till infinity. Not so. So if you go in this direction, it will also happen and will go to negative infinity. Not so. So if you ask you to write a solution for the y is equal to sine of x, and y is equal to a half, or where sine of x is equal to half. If they ask you to write a solution for that, could I list all the solutions that there are? Huh? You can't. Why? Because that's going to go to infinity. Not so. It's going to go to infinity. In the positive direction and in the negative direction. But if we look at this, remember that is going to be 360 there, not so. That's going to give you 720. What is 720 plus 360? 1080, no? 1080 plus 360. 1440. No? Plus 360 will give you that value, and so on. Go in this direction. This is minus 360. This is negative 720. That is negative 1080, and so on and so on. Not so. So to carry on in both directions forever. So what we do is we introduce something. Okay, before I tell you about that. If you look at this from day to day, this is one cycle, not so. This is one cycle. There. Going through that 360, no? That's one cycle. Here is another cycle. Here's another cycle. Here's another cycle. and there's another side, and so on. Not so. The cycle is here, going through there. I have to draw it neater, but okay. You guys get the idea. So this happens every, how much degrees? 360 degrees. Not so. So what I do is, I say, okay, from there to here, for that we let k equal to 0. Okay, we will bring in a variable. Okay, in that first cycle k is 0. Okay, you'll see now why. If we look at this, this is cycle 1. Let's call this cycle 1. So that is k is equal to 1. This is k is equal to 2. That is k is equal to 3. That's cycle 3. Cycle 4. And so on. So you go in this direction, this is going to be cycle negative 1, in the negative direction. K negative 2 and so on. Okay, negative 3. I'd rather not call it a cycle to be k. But if you look at the solution here, if I look at this 30 degrees here, each corresponding point is that value there. Not so. How many degrees later is that? 360 degrees. Can you see that? So starting off, k was 0. Can you see it? Take it from there to there, it's 1. So it's 360 degrees later. Sorry? No. If you look at the cycle, this was 30. This, what would this point here be? No, this is 360. That's 360. This was 30 degrees later. 390. But how much degrees is 30 to 90? 390. 360. Can you see that? How much degrees is from there to here? 360. From there to there? 360. And so on and so on and so on. Not so? If I go in this direction, this point corresponds to that point there. How much degrees is it from there to there? 360. 360. And so on. Not so? So in other words, if I must write that in general form, that will be x is equal to 30 degrees plus k times, it happens every 360 degrees. Can you see that? That's all. So if I'm more interested in this point here, then what is your k value here? 0. Not so? If k is 0, then that is 30 degrees. I'm interested in this point here. This is where k is 1. Can you see that, people? I put 1 in here. 1 times 360 plus 30, 390. I'm interested in this point here. What would k be now? 2. K would be 3. K would be 4. K would be 5. K would be negative 1. Let's check. It's 30 plus negative 1 times 360 is negative 360. Which makes sense. This point here would be negative 2, negative 3 and so on. You guys get the idea? So with that in mind, let's look at, I think I must take this off first. Just remember, that is 30 plus k times 360. So x is equal to 30 plus k times 360. If we take the other one into account, let's look at this one here. That is 150, not so? But that corresponding value will be there, not so? And then how many degrees is that later? 360. From there to there is how many degrees later? 360, 360, 360. This direction? Negative 360. Can you see that, people? So if I must represent that as a general solution, we will say x is equal to, what is this? 150 plus k times 360 degrees. Okay? So you want to pick up this point here. The k is 0. 150 plus 0 times 360 is 150. Can you see that? You're interested in this point here? K will be 1. K would be 2, 3, and so on and so on. In that direction, K would be minus 1, minus 2, minus 3, and so on. You guys understand? Well, what do you know now? Notice about the nature of K. Minus, you got 0, 1, 2, 3, 4. Well, what do you know about these numbers? What do we call these numbers? That numbers forms part of which set? If I look at 1, 2, 3, 4, 5, that forms part of the natural number set. 0, 1, 2, 3, 4, 5 all the way to infinity, that forms part of the whole number set. So which set of numbers does these form part of? What? Integers, yes. So we say K is an element of integers. You guys understand? Right, let's read what they say. So here, so if you look at this here, that was a restricted domain solution there. Right. If sine of x is equal to half, you should note that the graph intersect each other at the following values of x. Okay. So here we are told that x is equal to 30 plus n times 360. Instead of using n, we use a k. The period of the graph of y is equal to sin x is 360. For this equation, we obtain the solutions 30, 360. We got all this by putting 0, 1, minus 1, minus 2 into them. Okay? We'll look at more of those examples soon. However, there's another set of, right, we spoke about both. Okay? From this equation, we obtain the solution, right. Using your calculator, press arc sine of, right, that you'll get there. We mentioned all of those things, okay? You look at the solution here. On your calculator, press that. You get 30, right? In general, this is what I need you to write. Okay, we don't need to write. We're going to do an example, and then we'll formulate that that general note that I wanted you to write down that point, okay? So we're looking at the example, on which page is this? 210. Write that down and its reference. The question says solve for x, sine of x equal to negative 0,893. Okay, solve for x. The sine of x is negative 0,893, where x is an element of negative 360 to 0, correct to 1 decimal place. Now, I know there's a way of doing this without doing general solution. However, I always do general solution so that we practice general solution at the same time. Okay? But it is not a must do this way. Okay. Alright, so where do we start? Okay, we started by saying that sine of x is equal to negative 0,89. Okay. This, where x is an element of negative 360 to 0, we leave for last. Okay. You all okay with that? So the first thing we do is we isolate the trig ratio. So that's your first step. Write that down. We have to isolate the trigonometric ratio. What does that mean? Okay, write it down first and we'll talk about it. Isolate the trigonometric ratio. So what does that mean? You must get a trig ratio on its own. Is a trigonometric ratio on its own? Yes. Now what? Now we can solve the angle, the reference angle. Okay? So we say reference x equals arc sine, shift sine of 0,893. What do you notice? What do you notice? You notice you can use a calculator, yes? What else do you notice? Okay, she can't talk, but the hand is up. I drop the sign. What's on? I don't say negative 0,89. No? Why? Because we work with positive angles. We have a positive outlook on life. No? Yeah, I'm going to work with positive angles. Okay. There's people that work with negative angles, no problem with that. But I just work with positive angles. Okay? So whenever there's a negative there, I'll drop the negative. Okay? You all okay with that? So you put on a calculator, make sure you got a D there. On the calculator, I mean now. There must be a D. We shift, 9 clear. My calculator was in table mode for the graphs of yesterday. No? So, you press shift, sine, arc sine, 0,893. What do you get? 63,25. This is your reference. It says 1 decimal place. That is 63,3. So your reference angle is 63,3. Why do you think I said that it's a reference angle? Because that is not your only angle at times, and at times is not your angle. It is the acute representation of that angle. Which means to say that that reference angle is an angle between 0 and 90. You understand? So if it is the angle in the first quadrant, then it's that angle, theta. Can you see that? If it's the angle in the second quadrant, then it's actually that angle there. Can you see that's your reference angle? Or in that quadrant is that angle. Or in the fourth quadrant, it's that angle. Can you see that, people? But if it is in the first quadrant, it will just be the angle. Can you see that? If it is in the third quadrant, then it will be 180 plus the angle. If it's in the second quadrant, it will be 180 minus that angle theta. There, not so? If it's in this quadrant here, it would be 360 minus theta. You guys understand? That is why that reference angle is just that acute angle as drawn there. Okay. So the question we ask ourselves at this point. Okay, so firstly, we isolated the trigonometric ratio. Then we took the arc sine of that positive angle, of the positive ratio. Right there, this is your next note. Then you take arc sine, or arc cos, or arc tan, in this case it was arc sine, of the positive ratio. So if it's positive, you take the positive. But this was negative. So I take the positive part of it. That is called the absolute value. In brackets, it's the absolute value. So what's the absolute value of 5? What's the absolute value of 5? 5. What's the absolute value of minus 5? 5. Okay. That is absolute value. The absolute value of the ratio. Okay. So right, so that's the second note. Yeah? The third note is now we check in which, okay, now you must have, now we check in which quadrant sign will be negative. Now I'll explain to you now. Now we check in which quadrant sign will be negative. Now checking which quadrant sign will be negative. So, if this was a positive number here, then I would have checked in which quadrant sign is positive. But since that is negative, I'm going to check in which quadrant sign is negative. So what we do is we draw on the side here. All stations to Claremont. Remember, this is quadrant 1, 2, 3 and 4. In which quadrant is sign negative? 3 and 4. So I need to represent it in both quadrants. Can you see that? If sign was positive, then I would have ticked quadrant 1 and 2 and I would have represented in both quadrants. So again at this point, if sign is positive, it's going to be two branches in quadrant 1 and 2. If it's negative, it will be quadrant 3 and 4. If this was cos is negative, 2 and 3. If it was cos was positive, 1 and 4. Can you see that? It will always have two branches. No? And 10, if it's positive, 1 and 3, negative, 2 and 4. Always two branches. Are you guys okay with that? Right. So now we see it's going to be in quadrant 3 and 4. So we write here Q3. How do we get into quadrant 3? 180 plus theta, not so. And what's your theta angle here? 63.3. Make sense? So we say x is equal to, now I drop the reference. So I'm posting it to its correct quadrant now. No? X is equal to 180 plus 63,3 plus k times 360. Why 360? Because of the period on the sine graph is 360. Not so? So put that in the calculator. 180 plus that answer is 243,3. Plus k times. Can I add this, people? Why? Unlike this. Or how do I get the quadrant 4? So now you write that one down. What do you think that answer should be? Okay, so this will simply be x is equal to 360 minus 63,3 plus k times 360. So it's 360 minus 63.3. Oops. 296, comma 7 plus k times. Okay, and what must I not forget? That k is an element of integer. If you leave this part out, you lose 1 mark. Okay, k is an element of integers. So if the question was, Determine the general solution. You see, this is called the general solution, which means to say it is from negative infinity to infinity. Okay?
So,
yes?
you put that equation element of all integers on the outside as well.
You don't have to, but if you want to, you can. But if I write it once, I must not know that before that to know. Once is suffice. So as I said, if it's for the general solution, the question was read, determine the general solution of, then that is where you stop. You stop here. But the question wasn't for general solution. The question has a restricted domain here. Can you see here? It's going from negative 360 to 0. So we start off by saying k is equal to 0. So if k is equal to 0, then I put a 0 here, not so. Then it's going to be 243,3 plus 0 times 360, which is 0 here. So the answer is 243,3. But is 243,3 inside or outside this given domain here? Outside. Remember this from negative 360 to 0. So it's outside. So would I write that? No, I don't. That's not correct. Put away k is equal to 0 in here. Sorry, in here. Then it's going to be 296,7 plus 0 times 360. That falls away, so it's 296,7. Is that inside or outside? Outside. Do I need to write that down? No. Now, if 0 doesn't work, do you think 1 will work? No, because there's going to be even a greater number. Would 2 work? No. Would 3 work? No. So if 0 doesn't work, 1 doesn't work, you don't have to test for 7, 8, 9, 10 and so on. Make sense? So where do you think we'll go now? Negative 1. There we go. So we go to negative 1. Let's go. K is equal to negative 1. If k is equal to negative 1, I put in a calculator. 243, 243,3 plus negative 1 times 360. That's going to give you negative 116,7. Is that inside or outside? Inside. It's negative 116,7. Not so, people? Now put minus 1 in here and you see what you get. If I put negative 1 in there, what do we get? So it's 296,7. 296.7 plus negative 1 times 360 gives you negative 63,3. You all agree with that? Inside or outside? Inside. Then what's the next number I must check for? Negative 2. Not so. Now when you see k, you put a negative 2. What do you notice? It's outside. Not so. We're going to put negative 2 in here. So it's 243.3 plus negative 2 times 360. Should also be outside. Negative 476,3. Will you guys understand? So do I have to write that down? No. Do I need to check for negative 3? No. Negative 4? No. I stop there where once it's not working anymore. And then we close it. Okay, that sum is normally worth 4 marks, 4 or 5 marks. Okay. Sorry? Yes? To that? The brackets? We close it. Which brackets do you want to use? You want the curved ones? You can use it, but to list things, man. We list things in a squiggly bracket. But if you put it in a round bracket with a curved bracket with a block bracket, you won't get it wrong. It's only when you're writing interval notation, then you must write curve or block. No? You can't write squiggly brackets in interval notation. But when we list things, we normally list it using the squiggly bracket. Okay? We write it neatly for you, and you know what, when you see something like that, it's supposed to be this. No? That was normally what it looks like, not that Mickey Mouse thing. Sorry? I just said that means nothing. But when we list, there is just certain things we do, man. So if you list, when we list things, we list it using this bracket. But like I said, if you had put block brackets here, then you won't be penalized. You understand? However, if the question was for interval, to represent an inequality, and you take a solution, and you can write a solution either in inequality form or in interval notation form, and you choose interval notation, and then the brackets needs to be its right representation. You understand? Whereas this year they won't penalize. You see, we're nice people, man. We just want to give you marks, but you guys don't want the marks. No? Right, this is number 3. We'll move a bit faster through it. As you can see, we don't have much time left of the lesson. Number 2, determine the there we go, general solution. So where are we going to stop? We'll stop here. Verstaan julle? Ja, jy verstaan. As ek. Right, so what's the first thing we do? Isolate the sign with a trig ratio. So it's 3 sine x minus 3 comma 4 is equal to negative 4 comma 456. You take that over and you divide by 3. Work that out and you give me an answer. Okay, so what do we get? Negative 4.456 plus 3.4 divided by 3. I get 9, no, can't be right. Negative, what did I do wrong? 3 comma 4 divided by 3. The answer is negative 0 comma 352. You all agree with that? Negative 0 comma 352. What's the next step we do? Arc sign. We take it with the negative, without the negative. So do your thing. You write your answer in. And we call this the reference angle. Right, so what do we have? Arc sine of 0,352. Shift sine, no, arc sine. Shift sine. Whoops. What's wrong with me? Divided by 3. So you say arc sine of the positive part of it. No? 20,61. 20,6. You all agree with that? Now what? You ask yourself, yes? Which quadrant is signed negative? 3 and 4. All stations to Claremont, negative and 3 and 4. Now you write for me the general solution. Easy, no? Yes? If this was positive here, then the question you ask yourself, which quadrant? Sign positive. Then it would have been quadrant 1 and 2, yeah? Yeah? The reference angle would still be 20,6. Then quadrant 1 would have been 20,6 plus k times 360. Quadrant 2, it's 180 minus 20,6 plus k times 360. Okay? It's just too easy to believe it's so easy, no? I can't help it, man. Everything in maths is so easy. Right, let's go. We're quadrant 3. How do we get quadrant 3? So it's 180 plus. So x equal to 180 plus 20,6 plus k times 360. So x equal to 206. Is that correct? 200,6 plus k times 360. Quadrant 4. X is equal to 360 minus 20,6 plus k times 360. So x is equal to 339,4 plus k times 360. And what mustn't I forget? K is an element of. Okay. Okay, we'll do another one. That's all. What else you want to do? The general solution. That is a general solution. But when do we do that? If the question was to solve for x. Like here you're going to solve for x. Why am I doing this? What's wrong with me? Many things, many things. Crazy, no? You see, here, solve for x. Now we're going to go with that k is equal to minus 1, 1 and all of those. No? You okay with that? Kelsey, are you finished with this work already? Huh? Sorry? You're not, I thought you had this on the desk. I thought you were finished. Right, so what's the first thing we do? Isolate. So we say sine of 2x plus 10 equals So we're going to divide by 4 first. Not so. So divide by 4. So we got sine 2x plus 10 equals root 3 over 2. But what does that remind us of? Special angles. That is why it says without the use of a calculator. You just want to see the numbers, you don't want to see the words. Okay. So if this is 30, that's root 3, 2, no, it's 1, 2, root 3. Not so? So if this angle was 30, then this ratio should have been a half. Not so? So then what is the size of this angle? 60. Why? Because the sine of 60 is root 3 over 2. Verstaan julle? Ja. So then that means to say the reference 2x plus 10 equals 60 degrees. Can you see that, people? The reference 2x plus 10 is equal to 60. So what do we ask ourselves now? You see that 2x plus 10, we don't solve for x at this point. So make a note there. Do not break out the initial angle until we have taken it to its quadrants. Make a note there. Do not break up the angle, which means to say don't take the 10 over or divide by 2 at this point yet. Okay? Until we have taken it to its quadrants, posted in its quadrants. Okay. So which question comes to mind? In which quadrant? Yes? Sign positive. In which quadrant is sign positive? 1 and 2. So you take it to quadrant 1. No, not 90 minus. It is just the angle. Yeah. So we never say 90 plus or minus in general solution. Okay, when we take it to the quadrant. It is just, in quadrant 1, it's just the angle. In quadrant 2, 180 minus, 180 plus, 360 minus. That's all we do. We don't say 90 plus and 90. Okay? So let's do this before the bell rings. So what do I write here? 2x plus 10 equals 60, which is this theta, the angle here, 60, plus k times 360. Take 10 over, becomes 50 divided by 2 is 25. So it's 25 degrees plus k times 180. You see I divided throughout by 2. Okay, you guys understand? Let's look at quadrant 2. What do I write for quadrant 2? 2x plus 10 equals 180 minus 60 plus k times 360. Take it over, so that's going to give you 120 minus 10 is 110. Not so. Divided by 2 is 55 plus k times 180. Where k is an element of? What do you say? Hang on. There's a restricted domain here. This is, if it was general solution, I stop here. For restricted domain, I have to list x is an element of. Okay? So we start off with k is 0. So you put in the calculator. 25 plus 0 times 180. 25. Which is inside or outside? Inside. So it's 25. Now we go with k is 1. Okay? What I do is I do the one branch complete. Okay? So that's 205 inside. 205. Okay, is 2. 385, which is also inside. Okay, is 3. That is outside. So am I going to try 4? No. So now I try negative 1. That is outside. Not so. Now I go to the next branch. 55 plus k. If we're going to put 0 in here, definitely 55 is inside. If I put 1 times 360, 415 inside. Put 2 outside. Not so. But I'm going with 360, is supposed to be 180. 415. You got that? Phase 1. 2, 3, 5. Minus 1. Negative 125. It is also outside. So that is my value state. You will understand. Right. For homework. Homework I would like you guys to do exercise 6.8. Okay? 6.8, and that's on page 211. Okay. Before you leave, I just need to check something with you. Just open the group. Did you guys get that document? Okay. I need you guys to do the first 2 lessons from there. Okay. People enjoy the rest of your day. Good morning, class.